Hello everyone, a very warm welcome to everyone present over here. I'm Namrata Hari from SRMIC Ramapuram. Hack the Mountains 2.0 welcomes you all for today's session. It is really nice that all of you have taken up your time to attend the session and learn something new. Let's continue having the spirit for this event and for the upcoming events as well. We are delighted to announce that we have Elastic as a sponsor for our hackathon this year. The Elastic team has brought a session just for you hackers on the topic Elastic and importance of search and analytics with Aravind Putrevu. And Aravind Putrevu is a senior developer advocate at Elastic, and his experience in the field makes him more than qualified to guide you through this workshop. If you hackers want to know how to use Elastic in your hackathon project, this workshop is perfect to ask any questions related to Elastic and get the chance to win both headphones and other exciting prizes from the Elastic track. You can check further details from our related to this track on our hackathon website, and feel free to ask any questions here and in our Discord server. Without further ado, Hack the Mountains team welcomes you, Mr. Aravind. Over to you. The stage is all yours to rock.
Thank you, Namrata, and thank you, Hack the Mountains team. It's been my pleasure, throughout interacting with you right from the beginning, and I'm really glad that I could present something here. At the same time, I just want to make sure that the interaction is more than especially more than talking to me or me doing a monologue, etc. So I'm just gonna present a talk today, and this is a pretty standard talk. If you go by my sessions, reason being I presented this a quite bit time, and it's not something that you can't learn online, but the interaction is something that I look forward to with all of you. So if you have any questions, if you want me to stop me in between, even the organizers, Namrata, and everyone, just put the question on top or some and stop me in between. We'll make it as informal, as simple as it is, and less as like a webinar and something that I give and go away. Okay, so I just want it to be like that. And if you have any special questions which is not related to per se this technology as such, please do ask. That is great. So I'm Aravind. I work at Elastic as a developer advocate. Some of you might have met me in other hackathons or developer events, etc. But other than that, I run a blog at aravind.dev, run a newsletter at newsletter.aravind.dev, and I have a YouTube channel, all the stuff that all people do right now, and I have the same thing. So before getting started with the Elastic Stack itself, the technical presentation, I just want to kickstart clusters, a sample cluster, and then you could also do it when you are kind of when you're trying to build something on it. And we have given link to the organizer so that it will be shared to you, and then you can kind of use this platform to build your apps or whatever it is. But at the same time, I just want to without any delay, I just want to create this deployment, etc., etc. So I'm gonna use this say a enterprise search deployment to show you something on the search side of things. I'm just using Google Cloud. Of course, you could deploy in any other cloud. And then I'm gonna use Mumbai region because it's a bit near to me. And then I'm gonna name this as Hack the Mountain or HTM, which still works, and then create deployment. That's it. I didn't do anything special. I just chose search engine and then created a deployment, and it would create and show me username, password, and a lot of these details. But let's click get back and start the session. I hope there are not so many questions at this point of time, but then if you have any questions, I'll stop and take a look at it, and then we'll go ahead. So Elastic is a search company. Elasticsearch is a world's popular search engine, and you might be interacting with Elasticsearch every now and then. If you are if you had used Uber, because I guess nowadays we are not doing more rides, but then if you are ordering food now, you might well be using Elasticsearch even in India, because when you search for rides, when you search for restaurants, or when you are searching for a lot of different things, including you're searching for love, right? Which is really surprising even to me. When I joined Elastic, you could probably left swipe or right swipe and Tinder, and the results are coming from Elasticsearch. So there are many use cases. It's not just search. It's about a lot of other things, like be it analytics, be it machine learning, be it finding threats, and be it looking into your cloud infrastructure from a DevOps point of view. There are many things that you could do with Elasticsearch, and we'll take a look at some of these and how this engine would work. So primarily there are three solutions that is built on this stack. So I'll come to the stack part. What is this the module or the core software would look like? But then, like, these are three molded pieces that are there on the Elastic Stack itself. So firstly and foremost is the search engine, which is called as Enterprise Search, but it's not just like it. You can also, whatever I'm talking today is, you can download it and you can run it on your own laptop or your own hardware, etc. So basically, Elastic Enterprise Search is a place where you could pull in data from multiple data sources, or if you have a data set and then you want to bring in a build a search experience for your mobile users or anyone, then you could also use that. Say if you have a GitHub, if you have a Jira, or if you have your Dropbox, or if you want to unify your search experience, the workplace search would help you to do that. As the name suggests, it's a place where teams in the organizations where they have multiple data sources, different places, but you want to have a common search engine for the organization. That's where Enterprise Search can help you. Similar way, App Search, which is what I'm talking about, when you have a data set or when you have a website, can crawl and build a search experience for you. Similarly, you have the Elastic Observability. What it does is, like, it helps you to, like, find issues, bugs. It can collect logs and do log analysis. Some of you are very much, if you are doing the DevOps engineer boot camps, or if you are learning the infrastructure or cloud infrastructure, cloud engineer related aspects, you might very well be acquainted with the term called observability. And then, or like, you might be very well know about monitoring aspect of each and every software. So Elastic pretty much does this very easily. And then you could also, like, collect data sources, do a lot of stuff actually. And then you obviously have the security part, which is relatively new than other stuff. So we are also a security company. Search and security, how does it work? Because security also has a lot of data that you gather from various endpoints, various things. And then over a period of time, then our community have pushed us to do this as well. And then SIEM is one of the fastest growing solution on top of Elasticsearch. And all of that I'm talking till now is, like, you can go and explore. There is no paid thing or something like that. So you could go and try out, download it by yourself. So all these three solutions are powered by the common stack, which is Elastic Stack. And the stack at the core of it is Elasticsearch, which is the NoSQL data store, and which helps you to do a lot of things. That's what we're going to talk about today more. And then you have Beats and Logstash, which is the ingestion modules, which helps you to pull data from various sources. And Kibana, which is a visualizer which sits on top of Elasticsearch, which is a window into Elasticsearch actually. And then this entire software is like the platform agnostic. That means you could deploy on any cloud provider, and you could also host on your own custom data center. If you are one of those guys who have a gig at your home, a rack at your home, and then you are like building your own data center, then this is one another thing that you could look at. And then you obviously have the the deploying on Kubernetes part, wherein you could deploy the entire stack on Kubernetes. So all of this can also be deployed anywhere. So yeah, I'll just skip some slides. I'll stop here. I'll take a look at the the questions and etc. So that, like, I just want to know if you have any specific questions or any specific details. I'm kind of like happy to answer. Yeah, I see one question from Anmol saying, like, is the data stored in JSON? If yes, then why? Yeah, definitely. I'll tell you if why it is actually. Okay. So I don't see more questions, but if you have questions, please do ask in the chat. Feel free. And that's what motivates me to spend more time and explain you more details. Yeah, let's quickly go ahead and explain why you need JSON and why not something else. So basically, Elasticsearch is a distributed system. I don't know how many of you in your college has studied distributed systems, or it might be an elective for some people, wherein you could choose this paper or you could not choose this paper and choose something like an mobile computing or something like that. But then distributed system is very complex, and then and it also is very exciting, because it works like real world. So Elasticsearch is a distributed system. It's an horizontally scalable system. Horizontally in the sense like it scales like this, not like this. So it's not a vertically scalable system. It's an horizontally scaled system wherein it does parallel computing. That means when you send a search request, it will spread that search request across the, the nodes, and collects all the details and sends it to a common, the client that is asking the details. So it sounds very much like, if you have heard about like distributed search and all of these things from Google and like stuff, you could do all of that with Elasticsearch. You could do did you mean, you could do a lot of these things which are search specific. You could do phonetic search, you could do a lot of these interesting things that with Elasticsearch, only in the search part actually. And there are more things that are going away, like going apart from all of that, that we are not actually talking about. So that helps you make this Elasticsearch is a great thing. So I'll just bootstrap you with some knowledge of the terms, because I might be using some terms which you might not be very well acquainted. By this time, I think you might have a lot of questions as well. But then I just go with the terms actually. So Elasticsearch as it is a distributed system, and you have multiple nodes, and then so that is why it forms a cluster topology. I guess you might know about the topologies, star topology, and like different type of topologies that it can form in the networks as well. So in a similar fashion, it forms a cluster, like a group of nodes communicating together and work to the common problem, like serving the user's request, whatever the software is designed for. So in a similar distributed systems fashion, the nodes come together to work. Now, what is a node? Again, any node that runs an Elasticsearch process is and it's part of your cluster is an Elasticsearch node, and all bunch of these nodes will come together and like kind of solve this problem. And then like I said, you just need to go download open your terminal, unzip Elasticsearch, go to bin, start Elasticsearch, and then you open another terminal, go to bin, and like start Elasticsearch from the same thing. Of course, your data directories might need to be different, but then like you can build a 3-node cluster in your own single laptop. Ideally, it is not recommended for production, but you could try in the dev control actually. And then the node can be a virtual machine, your laptop, or a container, and can run in any OS. Actually, we are platform agnostic, vendor agnostic, cloud agnostic actually. So you could run it anywhere. And just small tidbit, like Elasticsearch is written in Java, and there are other modules, and like Logstash is written in JRuby. We are actively moving to Java. Beats is in Golang, and then Kibana is in Node and React. And each of these projects accept contributions. You just need to go to this issue and just find for a good first issue, or up for grabs kind of a label, and then you would be able to contribute it. There are many other projects for UI engineers. You could go and look at EUI so that you could find out related contributions as well. So yeah, now coming back to the topic again, Elasticsearch contains indexes. It doesn't contain tables like your RDBMS system. So indexes is the place where you store all the data. But index is like a logical reference. It's not a physical reference. Index is a place where you have all of this data that is referred by a name. And so, for example, this is how an indices could look like. Like if you have 3-node cluster that we have shown previously, you have an apps index, meta index, and content index. And like each index might be containing a specific amount of data. But remember, the data is spread across the nodes. It is not situated in one place. It is spread across the nodes. That is the important thing that you need to look at. And then I'll also introduce some more concepts which might be confusing maybe at an initial stage, but like just bear with me. I'll explain you in a graphical manner as well. So a shard is something that like kind of divides this index into a small buckets, like containers of data. Like I said, index is your logical reference, not your physical reference. Say for example, a shard is something like the real disk that is getting the data that is stored on the disk, like a chunk. But then the index is like a logical name that refers all of these buckets across the index. So for example, if you take this index colored in yellow itself, it contains multiple shards, but each shard might be in a different node altogether. But when you are referring, you refer to the apps, like say select star from apps, but you would be talking to all the shards which are spread across. That's why I'm telling it's a distributed system. It's also a parallel computing engine, so that you will be able to do that. So there are different types of shards. I'll not go deep into it, but you could go and read about it. Like primary shards, replica shards, each shard does some specific stuff. I know it gets complex, and probably you might be worried, and it might be a lot, but it's simple. Each shard has a specific reason and why it is doing all of that. And coming to the question that Anmol asked here is why JSON, and why not anything else? So Elasticsearch is a JSON store. It was initiated in a day where JSON data stores are really popular. And actually, if you see, a lot of content still in the world is mostly used. JSON is mostly used. Of course, there are many other formats that people use, like gRPC uses different sort of structures, etc., etc. But then JSON is still the very popular way to send and receive data. Elastic as a company, all the developer products that we build and use are they eat JSON, drink JSON, sleep JSON, and YAML is our configuration language. You will see .yml files as a configuration, to set configuration as well. So there are many other JSON document stores as well. You have MongoDB, you have Redis, you have lot of systems which use JSON as well. So it is even NoSQL data stores mostly use this particular thing. Even MySQL uses JSON now. They have a component actually there. So yeah, this is what we have explained. I'll take a break here and again come back to you to talk more about it. Say you have 3 instances, indexes, shards, and documents, etc., etc. So this is how it is configured. Now, according to the image that I have shown you previously, it is not like the index is only linked to this particular instance. It will spread across the nodes. So just excuse me for this, the diagram which is showing not appropriate depiction. I need to change this actually. So yeah, other than that, everything is similar, and this is how you see the data. Actually, the data internally is not really stored in JSON as is the JSON. It looks like it emits JSON, it takes JSON, but internally it stores in a different sort of data structure, and using a system, a library that I'm gonna introduce you in a minute actually. So any other questions other than that? Okay, I think you could. There are some more questions, I guess, if someone could highlight that, and I'm happy to take them and answer. Yeah, how indexing works in Elasticsearch. Indexing, I'll explain that. I have some more slides about indexing actually. It's not so complex to not being able to understand, but it does a lot of things in a nick of the moment. I'll also tell you those details actually, and help you understand that. How we can contribute if you don't know anything about it initially. So specifically, it just look for a good first issue. Try to contribute to the docs. Try to write a blog post. We have a contributor program running. Of course, I don't have the link right now. I'll probably paste it at the end in the Discord channel or somewhere. But then you could write anything, and like a blog or a summarizer or anything, not specifically code, where we still happy to help you actually. And then I'll explain how, as a beginner, you could use Elasticsearch. You just need to know about the various APIs that are there, and those API documentation, again, I have given as a link, and then you could probably get it at the end of the session. Okay, so another question from Arun, saying that how do you send data using Logstash? I think all the times you don't need Logstash. So many people think that Elasticsearch, Logstash, Kibana is the set, and Elk is the cluster that you need to build. I don't really say it is the standard way. I would say it is not actually. So what you could do is you could directly send data to Elasticsearch using one of the other REST clients. Again, I have some slides. I'll talk about that. Okay, so I think there are more. Please keep your questions coming. what I'll do is, like, because I have some slides in the upcoming session, I mean, in the session to come by, I will kind of like automatically, I'll go ahead and take those questions, and then like probably like again, when I come back, I'll answer those, because some of those questions are related to the slides that I'm doing next time. So Elasticsearch has node roles too. Like while I spoke about multiple roles and a lot of stuff, you can give the role to a specific node and it will do that work. Okay. So usually, if you think of doing a small size like meeting or a get together, right? And there is no separation needed for each people to do. Like some will do cooking. You don't need to assign people. Everyone can do everything. Like in a party, like some people can do cooking, some people can do like arranging the tables or something like that, or everyone can combine and do. But if you are doing a large party, or like if you're doing a festival, or like a conference at your college or somewhere, then you need teams, right? Each team, like there is a promotion team, there is a team like just this hackathon, right? There is a team who looks after speakers, a team who goes to sponsors, there's a team probably who is going to do set up all the infrastructure which is needed for stuff. There is a person who is going to engage with you on the Discord. So the roles are defined. In a similar fashion, in the distributed systems, most distributed system have roles, from what I have learned, like Hadoop everywhere. In a similar way, like Elasticsearch has its node roles. What you could do is, like, you could have a master role, data role, ingest role, and ML role. Say you could use ingest node to, like, give all your, it contains some APIs, and then like you could route all your data to the ingest node, and the ingest node will help you to transform the data and like put into Elasticsearch. So that is one another way to kind of like look at stuff. So a lot many people keep asking me that, or directly ask me, or like indirectly ask me, like, is Elasticsearch powered by an RDBMS system like Oracle or MySQL, or what does Apache Lucene do? Like, or Apache Lucene is everything and you guys don't do anything. Like you just like are masquerading something around it. Not exactly. There are a lot of things that Elasticsearch does, but we recognize and we really admire Apache Lucene as a company as well as a team, etc. Because Lucene is a full text library. It's a jar. It's a Java jar which contains all these data structures, etc. We actively contribute to Apache Lucene. Again, Apache Lucene is a open source project. So what Lucene does is, like, it's a Java jar. You could put it in a Spring Boot application or a Quarkus or a whatever the framework that you are using, Java framework. You could put it and you could use it. You could build a search engine, but it is only for that programming language. What if you are using Go? What if you are using Rust? Or what if you are using Python, right? So you need to, as a developer, you need to have that accessibility to that particular great library. And also, like, it's not just a single library. You want to store your data and make sure that someone gets you the data like a data store, right? So your data should not die when your application dies, right? So Elasticsearch is born with that notion, like, to serve the to make a full distributed search engine, which is very large scale, which does a lot of stuff actually. So it, like I said, it's great for full text search, and then but it's a bit challenging use and not designed for scale. If you have more questions, or like if you want to go deep down, I saw someone was asking like how indexing works in Elasticsearch, and this is what I could take 45 minutes to explain from now on, but I don't want to, and I want you to learn more by yourself as well. Like, so this is a great blog. There's it's a bit old, but a lot of core concepts are still same. Like you would see found Elasticsearch top down, like explaining like how from a request to how it goes down to find a data. Similarly, there is an Elasticsearch bottom up blog post. You could go and lead that, like just the same, but you replace the top down with bottom up, and then you will see two different perspectives of doing that. And someone also asked about the full text search question. I'll come back to that actually. So how do you talk to Elasticsearch? So someone was saying like, I can't kind of like send in data to Logstash, etc. So talking to Elasticsearch, actually there are multiple ways, because it's a API defined system. You could use curl. I'll show you an image actually, and then I'll show you the API expandability of what and all are there in Elasticsearch, and then how you could use that. So if you see curl, you could do a curl call, which is just a tool, just like Postman or Insomniac or like Hopscotch or whatever the tool that you're using to just call APIs, right? So you could use the API call and send the details. And then you also have these different language specific wrappers around it. Like you could download this Java client, and then say Elasticsearch is equal to new Elasticsearch, and give the IP, and then you could simply start making calls like elasticsearch.create index search. You could do that. Similarly, in Python, you have a Python library, or like you have a Go module or something like that. So you have everything. Like we have clients for Lua, we have clients for Perl. So just imagine that you have everything. So, and all of them as open source. Again, someone was talking about contributions. So just need to like have see the API. If the team wants that, you could contribute to the clients, and it's Apache 2.0 clients, and probably millions of clients are millions of people. Like there are so many use cases, and many people use our clients. So your contribution will run in multiple web servers. So just you could also do that, and it's a fantastic way to start your journey in open source. And then if you are like me, like lethargic and not interested to write code, and then probably want to do some configurations and get data into Elasticsearch, you could still use Logstash. Logstash is an interesting plugin called Twitter, so you could go and track it, Twitter trend. You just need to generate API key from the Twitter, and then at developer.twitter.com, please do try it and ingest data into Elasticsearch. So that could be a very good tool to kind of do it. You could write plugin extensions to Logstash itself. That could be your project as well, because there are so many plugins written by community. There are more than 350 plugins, I guess. Similarly, Beats is like a data shipper which helps you to build this entire stuff actually. So again, the details are here. You could go and learn about some of these clients, like these clients specifically. Logstash and Beats have their own documentation system. So I just gone really fast, but then if you are kind of looking to build, what do I build? How do I connect various stuff? So as I said, you could directly ship data to Elasticsearch. You could use Logstash in between to do some stuff, and then send it to Elasticsearch. And then you could also use Kibana to do stuff. So now what I'll do is I'll also show you some stuff, not just talking all the time. I'll just show you some details here, and then probably I'll kind of take more questions as well, so that you are well equipped to probably answer me later. So that you will also get something to build in your hackathon. So whatever I'm going to show you now is something that you could build like a search engine actually. So you could click on the launch app search. This is a search experience if you are a front-end developer, if you are using say, what do you call a React.js dev or a JS dev that you want to learn more, use Tailwind kind of projects or Svelte, etc., etc. So you could simply use app search to build some nice search experience or nice mobile app, etc. So I'm just gonna do some interesting stuff here. I'm just gonna use crawl a website and then create a search experience on top of it. Hopefully it works. So my search engine name is GH search. I guess if by this time probably some of you would expect what GH is. GH is nothing but the the GitHub. You could also upload JSON, like I said, JSON file and the data set, or you could also use the API to directly send the data. But then I chose the web crawler to crawl the data actually. Let me quickly, and all of this experience that you are seeing, it will go into the Kibana world. But now it is a separate UI, which is going to be migrated to Kibana, so that you will be seeing more of the stuff again there. So let me quickly go to the GH page. So I guess some of you would know that GitHub has introduced GH client, like the official command line client for the GitHub. So where it's cli.github.com, where there's a site, and then it contains a bunch of commands and manual and a lot of stuff. So what I'm going to do is I'm just going to give this cli.github.com as my site. So, and then crawl this site, because there is no search bar here. And me as a search dev, I can't see nothing with search bar. It's of course a small site. You might not need a search bar. Control F would work. But then just for fun, I'm just trying to create this cli.github.com. And then I'll click on setup.domain. And I could also probably create a sitemap.xml. So most sites will have the sitemap.xml, which gives you the structure of the site. So I don't think it has. You should also see about what do you call the robots.txt, which tells you whether the site should be crawled or not. Every site has, everyone, Facebook has, every web entity will have. So just see that what happens if you don't have is like they just need to they'll just block you. Actually, that IP will be blocked. So I'm just gonna set up the sitemap, and then I could also create a crawl rule. So as much as I do everything in UI, you could also do it via API. I'm just doing the stuff here, like allow or disallow. I could set a specific disallow rule, etc., etc. I'm not going to do that. It's going to scan everything. It might kind of like take a bit of time, but I'm kind of like going to let it happen and see the documents that are getting ingested here. And the important and interesting part in all of this is you could create the search experience in just say 10 or 15 minutes as the crawler crawls and builds this search experience. You could use the again another library to kind of uh, like create the search experience very easily on top of the APIs that are there. So that is how you could build a search bar. It is not done yet. I think it will take a bit of time, but meanwhile I'll take more questions as we speak. I think my internet is getting slower and slower and slower. Um, but yeah, we have seen first document here. So similarly, you could use Elasticsearch to kind of like do different stuff. This is just a search experience. You could go to the Kibana here and explore Kibana and build what you call operational system, collect logs, metrics, and traces, build analytics on the data that you ingest. I'll just try to show some more stuff there as well. And then before I get to the question, I'm just adding the sample data here. So Kibana is a UI, and through which you are querying Elasticsearch, ingesting the data and like querying the Elasticsearch through that stuff. So let me add this data and show you some information actually. So as and when it gets added, I'll show you how the real request look like. Say if I want to go to the dashboard, wherein I see the analytics, and if I go and click, say this is an e-commerce data where I'm seeing that how do I know how the data is split between different things, how the sales happened. I clicked inspect, and then I could download this data, but I could also like go to the request and see how request and response happened, like where it has happened. So it's an aggregation query based on customer gender, and is saying like do descending, and then size is 5. So this is just a query that has happened, and your client, if you're using some programming language client, it will do it by itself as well. And this is the response that it got, like female is this female is this. So the beauty with Elasticsearch is it can do structured querying, unstructured querying. It can do semi-structured querying, like structured querying, like select star from EMP, fully relational. It can do unstructured querying, like just go and like search for Aravind, and just it finds heaps of data. It will simply find the relevant results, right? Like a search engine. And then it can also do semi-structured querying as well, like somewhere in between, not fully structured, not fully unstructured. So the good thing is like you have also like a JDBC client wherein you could query Elasticsearch with what you call the SQL. So let me show you that as well. So, and like if you could use SQL to like talk to Elasticsearch, I guess, because a lot many people would naturally know Elasticsearch easily by this way. And I just want to like say select star from table, right? What is this table? This table is a table that the index name itself, like say if I want to do get cat indices, then I see a lot of indices. But don't worry, this is because we are crawling the site, and like there are a lot of stuff. But there is also one more information that is like sample data e-commerce. That's what we added, sample data. So I'll do this, and then if I enter, it'll give me, okay, so there is some data that I didn't properly do it. But you could also do show columns. Like you could do multiple stuff. You could run queries, and you could run all of that actually on Elasticsearch. I don't know if it works, but I'm just trying out because there might be some information. So you could run SQL queries on top of Elasticsearch as well. That is an easiest way also to look at things actually. So yeah, I think while we spoke for quite some time, I guess this should crawl data and show you information. Okay, ready. So I have some data that is coming up here. And then now this is a reference UI. There is a React.js library, that open source library that we have, through which you could build a search experience like this. It brings in your create React UI app and folks that, and creates an experience on top of it. Like I'll show you what it is. Like you have a title field, and you have what do you call filter fields. Like you might want to like filter with say there might be many things actually, and then like sort fields, you can sort the field with something uh, like you know I don't know like if it is possible. And then URL field, obviously URL, and then just click generate quick preview, and then it will generate that. So if I want to like say what is the command for PR, and then it shows me all the relevant stuff. What is the command for checkout, right? It'll show me the checkout related information. And I could also adjust this one. I could download this zip package and do npm start. It will open up on localhost 3000. And then I put my own CSS on top of it, use something like Tailwind or whatever it is. I could also tune this results. Like say, I could tune this result to show me the relevant information. Like I could say, okay, give more value to the title field, adjust the weight so that it changes and gives more value to that. Like let us restore the defaults, and I'll also show you synonyms as well. So you could create a synonym set, like say Aravind is equal to PR, like pull request. So if someone types for Aravind, and you will see let us try in the query tester, I guess. So it'll take me, it'll show me results which is in my name. As you know that there is no chance of having PR in a data set that is about GH client, but you will find that stuff like that. So there are many things that are there, and I would I'll stop talking and I'll take more questions. And yeah, great. I guess let us take some questions, and then we'll talk more about the project, etc. Which question will start? Okay, what is full text search? I guess like this is a good question as well. So specifically, there are many interpretations. Like say, if you have a large swath of text, and then if you just want to kind of you just want to probably like search on top of it. Like say whatever we are trying to do right now is just like kind of a full text search, and then you want to find out relevant results. Like say for example, you have a link, a blog post, and the blog post contains a lot of data. How is Google is searching about it? Because it crawls all the data, ingests that, and does this full text search analysis. Full text search analysis, it analyzes the data. It knows how many times a word is pronounced, actually a word is written in that. Suppose if it does that calculation, it uses a specific algorithm, which is the famous page rank algorithm. Like Elasticsearch also uses that algorithm. I would definitely give you a homework kind of a thing, so that you go back and find out what algorithm that Elasticsearch uses behind the scenes to find out the right search results. It's interesting, and you will also get to know more about full text search as well. And how using Elastic we can prevent us against security threats. So Elasticsearch is a tool. Like as I said, I'll just show you this particular thing. Say for example, what do you call? So if you are like using, I'm just want to show the product page, because that is easy rather than I spinning up everything. So Elasticsearch can be used like an SIEM solution, like security information in eventing management, through which you'll be able to collect data from various sources. When I say sources, it could be your IDS, IPS, endpoint, network data, and various sources. And then when it comes to Elasticsearch, we have tools, we have detections, we are integrated with popular frameworks like MITRE and MITRE attack correlation techniques, and through which you'll be able to like kind of visible, I mean, you see all the data that is coming up in different sizes and shapes. That's why that is the thing that is being given here. If you're curious, you should definitely see this video, and this video gives you a great insight into what's happening. So it's just elastic.co/security. I can go on again, like talk about EDR, EPP, what we are building, what is Elastic Agent, how we are trying to get different types of data. There are recent there are recent blogs about process isolation and a lot of different stuff. I'll stop here, but I would definitely recommend you to go and take a look at it. And like this is very popular, getting very popular, and a lot many security teams are very much interested in it. So okay, I think I spoke about Lucene, and then yeah, of course, like Anmol, I failed at showing SQL basically, but then it is possible, and you can do that as well. So you could fetch use SQL to fetch data from Elasticsearch. There are few caveats. You can't do transactions, you can't do joins, but other than that, you could do correlated queries. You could do a lot of stuff, other stuff actually. Okay. Another question from that one is like difference between mapping and scheme. So so I think you are asking about schema. So Elasticsearch is schema free. So whenever I'm trying to ingest the data, say for example, the same sample data e-commerce, it contains a schema actually. So what is that? So I'll give you that, and then mapping. So mapping is your select like when you're creating a table, you have to create table name and name varchar, and then you look then you do like empid number. You do that, right? Similar way, the definition of that variable or something like that. So is the type here, that name. So that is what is called mapping. So this is you could also call this as schema, right? You create a schema for your data model, right? So that is what is given here, like schema and all will be given here actually. So if you could see, okay. So this is how you could take a look at everything. So yeah, thank you. I'm here after hackathon. And then what does Elastic Stack specifics? I'm not sure about the question. Yes, there are specific video tutorials, etc. So you could go to the the learning part. Okay, I'm sorry, I'm at the wrong place. So you could go to the either community and join the Slack channel. We keep putting a lot of stuff there. And then otherwise, if you want to get into some training, you could definitely like do the free training. There are so many free training courses, quick starts as well, which helps you to like learn what is Elasticsearch, how things work, and it offers you an environment for you to like kind of practice stuff as well. So say for example, how to's, there are how to's as well. There are fundamental courses as well to understand the terms and a lot of these details. So do visit that site, and then you could learn more as well. Those are the video lectures. Obviously, you could attend webinars as well. There are so many webinars every week, and then you could join that. How can we use Elastic in our project? The multiple ways, like I said, Elasticsearch is a data store. You could use like a database. You could use it like an analytical engine. Like I said, there is a challenge that I have given. You could read that and understand, like, build a puzzle, build a game. You could build an app. You could solve a solution. You could build various stuff. You could build a playground for Elasticsearch itself, like get a data set, how each API would work. That itself is a great educational project and a hack project that you could use, right? And then yeah, that's about it. And yeah, if you have any more questions, I'm happy to answer. I am nearly end of my session, and then like I don't have anything specific to show, but yeah, if you have any specific questions, I'm happy to take it right now. Okay, so that's it from my side. If you don't have any questions, and I guess like I kind of like shared good amount of details to you. So I'll show you some more information here so that you can go and like learn more about Elastic. Brown bag is the link. But if you feel that if you want to like drop an email or DM me, obviously on Twitter, or you could also create a discuss.elastic.co, a post there, and wherein you could kind of like create questions and ask stuff actually. Yeah. So that's it from my side, and thanks Hack the Mountains organizers for a fantastic experience again. I really appreciate the time and the opportunity that you have given.
What a positive energy we received in the comment section. That's really cool. Such an informative session. Thank you, Aravind sir, for taking your time off your busy schedule for being with us here today. It was amazing to hear out the valuable insights you had for us. I'm sure the audience loved listening to your session. Also, thank you, wonderful audience, for tuning in. Don't forget to check out the Elastic track, join the Elastic community, and also check out the Elastic doc so that you can implement Elasticsearch in a better way in your projects. If you have any doubts, go follow Aravind. Feel free to ask questions in our Discord server. There is a special booth for Elastic too. So if you have any further questions, don't forget to ask us there. Mentors are always available to help you out. Then before we sign off, I would like to mention that the feedback form link will be posted. So do fill it up soon so that you are eligible to grab your Hack the Mountains participation certificate. Yeah, that's it. And if you need any more details related to this sponsor track, check out our hackathon website. All the details are given there. So I guess that's it. Thank you everyone for being part of the session. Very nice audience. Bye. Good evening, everyone.